So now let's continue our discussion with this idea of something called quadrantial angles. Quadrantial angles are defined as angles that terminate on the x or y axis. Now keep in mind this definition that we talked about in the last video right here, which was that if we have an angle in the plane, we can define it in terms of the x and y coordinate and a hypotenuse equal to the square of the sum of the squares of the x and y values right here. Well, what does that mean for us if we have an angle that actually terminates on the x or y axis? Well, if we terminate on the x-axis, and let's just pick a point right here on the x-axis, let's even make it a very simple point. The point 1, 0, right? We have an angle formed in standard position starting at the origin through the point 1, 0. That is the angle 0 degrees, right? So theta is equal to 0 degrees. What do we do with that? What do we say? Are there any trigonometric functions of this particular angle? Well, yes. In fact, we can say the following, right? We treat this as a triangle in which we say if x is equal to 0, x is equal to 1, y is equal to 0, then by the Pythagorean theorem, h is equal to 1, because 1 squared plus 0 squared is 1 squared. So, for our trigonometric functions, what can we say? Well, in the case of 0 degrees, we could say that the sine of the angle 0 degrees, or 0 radians for that matter, is going to be equal to opposite y over h1. That's 0. The cosine of our angle 0 degrees will be adjacent x over h, hypotenuse 1, so 1 over 1, that's equal to 1. The tangent of the angle theta equals 0 degrees is going to be y over x, opposite over adjacent, that's 0 over 1. We're back to 0 again. And then finally, for our other trigonometric functions, we might say, well, the cosecant of the angle 0 degrees. Well, because we would be taking the reciprocal of the sine, which is 0, we're going to call it 1 over 0, which is undefined. Okay. And we could similarly go about each of our angles right here, but the secant of the angle theta, 0 degrees, would be equal to 1, and the cotangent of 0 degrees would again be undefined. Okay. Now, what you need to do is you want to check out the table on page 456 to see what's going on. So page 456 in your textbook actually lists out all of these values for our trigonometric functions. I will go through our quadrantial angles just so that you see what's going on right here. Another quadrantial angle would be our 90-degree angle, our right angle, right? 90 degrees, or pi over 2 radians. We're at the point 0, 1, so now you can start defining in terms of 0 and 1. Our main three functions in this particular case inform us that the sine of the angle pi over 2 radians would be equal to 1. The cosine of the angle pi over 2 radians would be equal to 0. And this time the tangent of the angle pi over 2 radians would be undefined. However, on the other side of the ledger right here, if we were talking about the cosecant of the angle pi over 2, we would be talking about 1. This reciprocal of the cosine, which is the secant of the angle pi over 2, which is going to be equal to undefined, right, because we're dividing by 0 this time. And then finally, the cotangent of pi over 2, which is going to be equal to 0. Further angles that we will deal with, Back over here at -1, 0, we're talking about a straight angle, that is to say 180 degrees, also known as pi. Check out your table for those values. And the other quadrantial angle that we need to know is 270 degrees. 270 degrees, which is the same as saying 3 times pi over 2, 3 pi over 2. And then finally 360 degrees brings us back to our original start, right? Or we would say 2 pi radians, right? This is in the same position. So check out your table there on page 456 to get an idea of what all of these values are, and we will use these as part of our exercises. More to come in the next video.